Nous allons passer à l'exposé suivant, qui est donné par Alexander Batkhin, et dont le titre est Hénon Generating Solution and the Structure of Periodic Orbit Families of the Restrictive Free Body Problem.
Voilà, c'était sympa, ça. Très bon. Professor Frisch mentioned in his talk Russian mathematician Vladimir Igorevich Arnold. So I want to start my talk with a small episode. Arnold had an opening talk on a conference devoted to centenary of Kolmogorov. And Arnold said, excuse me. Thanks. So Arnold started his talk with words of Henri. Henri said that for mathematician to make a talk in foreign language is the same as to talk from prison. I'm not Henri. I will talk in English. So at first I want to thank for organizers for opportunity to have a talk at this international workshop, especially to Professor Chinsenet. And I want to say a few words about our contacts with Michel Hénon. It's a pity, but I have only contacts through email. It was a period in my life when I changed my place of work, and I started to investigate periodic solutions of some celestial problems, and especially I was interested in periodic solutions of Hill problem. And from one of the after one of the conference where my work was criticized, I decided to write a message to Michel Hénon, and I want to understand, maybe I not in the right direction I move. The first reaction of Hénon was I did not understand anything in Russian. By the way, I wrote him in English. Yes, just a moment. I did not understand anything in Russian. It seems to me Hénon was afraid that I want to him to write for me such a formal words for something. But in a few days, I obtained a new message. So where he supported my work and where he said that it's very interesting. And he proposed me, he gave me very interesting advices and recommendation how should I continue my investigation. And maybe one of the last Michel Hénon papers devoted to periodic solutions of the Hills problem, and we discussed with him some new solutions, and at that time I did not publish my paper, and he wrote in the reference from private communication. It's for me very pleasant to remind. Well, but in my talk I want to tell you a story about such a kind of scientific competition between Michel Hénon and Professor Alexander Bruno. For last 6 years, I work together with Bruno, and last week we spent 2 or 3 days, and Bruno told me many interesting details how this competition took place indeed. But it's from the point of view of Bruno. Maybe it's not the real situation. Here is an evidence the only possibilities when Bruno and Hénon met each other at Nice. It's 90, and here is at Nice, at France, where Bruno was invited for 3 or 4 months by Professor Chancenet in Paris. But Bruno had a trip around the France, and he visited Nice. And at Nice, he met with Hénon and discussed something. So it's in August, very hot. And Bruno, even in Moscow last year, May was very hot, above the 30, and Bruno was just a topless. So it's quite normal that Bruno now in shorts at this picture. I want to say that, on my opinion, there are 2, in theoretical mechanics, for example, 2 problems that influenced on development of many branches of modern mechanics, on modern mathematics. It's a problem of rigid body rotation with one fixed point. And another one is a 3-body problem. And maybe most simple variant of this problem, the restricted problem, attracted interest from many famous mathematicians, from Euler, from Lagrange, and if we continue this list, we'll go to Michel Hénon. So, restricted 3-body problem is maybe very simple to formulate, but it's too difficult to understand the structure of the phase flow. And to understand the structure of the phase flow, we have to investigate the structure of periodic solutions, the structure of families of periodic solutions. And here I want to show the place of circular planar 3-body problem in such a hierarchy. And I show that in red, I show such variants of problem where Hénon made progress. First of all, it's circular restricted problem in the case of Copenhagen case, where 2 masses, active masses, are equal. In the limit case in Hill's variant, where we investigate the movement of the massless body around the minor mass. And I think that Professor Bruno is right. He decided to call a particular case of Hill's problem by the name of Hénon, because Hénon used this particular integrable case to understand the structure of families of periodic solutions of Hill's problem. So certainly if anybody mention a periodic solution or families of periodic solution, he has to mention the words of Henri Poincaré. For what purpose we have to investigate this periodic solution? But 3 months ago, I have a talk with Carles Simon, and Simon told me, well, it's fine words, that's okay, but at the current time, periodic solutions is not enough. You have to investigate more invariant structures, especially central manifolds. And here is words by Victor Sebihay, where these words may be enough characterized the restricted three-body problem, because from the one side is a problem which arises from applications, and from another side, this is a source of many methods, of many interesting results. I think that, in brief, I tell a few words about this problem. So we have two active bodies, the Sun and the Earth. And the Earth rotates around the Sun in plane, uniformly, along the unit circle. And we have the third body, massless body, like a satellite, like a moon. And here is a picture for the limit case when the mass of the Earth is infinitesimally small. So the interaction between M2 and M3 may be neglected. If we move as earlier proposed into a rotating frame, we obtain active masses fixed. And in this case, we have to investigate how move massless body in the gravitational field of these fixed gravitational centers, but in non-inertial rotating frame. Here is a Hamiltonian. I wrote this Hamiltonian in the form of perturbed Hamiltonian. So we have an unperturbed part which describe a Keplerian problem in rotating frame. And here is a perturbation of it, where mu is a mass parameter. It may be very small. It means that we can investigate this problem from the limiting case, from the case of Keplerian problem. So I think I'm right if I say that Hénon has 3 blocks of papers devoted to three-body problem. The first block is 6 or maybe 7 papers from 1965 till 1970, where he numerically investigate in these 2 papers, he numerically investigate periodic solutions of the restricted three-body problem in the case of equal masses. It's a Copenhagen case. In my opinion, he used this special case because at that time there were no technical reports of Brook, and the only numerical computations of three-body problem was provided by the Strömgren group, Dutch celestial mechanics, before the Second World War. He published results of his group devoted to the case, to Copenhagen case. So Hénon decided to use his numerical methods to check the computations of Strömgren group and to understand maybe new effects in these results. I want to mention that, first of all, in these papers, Hénon show us very accurate and thorough numerical computations. So he recompute many periodic solutions that was found above. He used new technique for me, this Poincaré map technique. And he investigated new solutions very interesting with asymptotic behavior. Here is two pages from the first and from the second paper, and at left you can see the characteristic of the periodic families, and here is a very interesting characteristic with asymptotic behavior where we have spirals, and new periodic solutions which demonstrate such asymptotic behavior were found out by Hénon and described him. The next paper was devoted to the situation of restricted three-body problem when mu tends to 0. Mu is very small. It was two papers in Bulletin of Astronomy, and then the common big paper with 10 or maybe 12 tables of numerical computations. In this paper, Hénon for the first time used the technique of generating solutions. This technique was known from Poincaré books, but Poincaré used this technique for regular case, for case when the generating solution far from the singular point. And Hénon tried to use this technique for singular case. And here, in this paper, he demonstrated a very interesting equation, which he obtained to understand when collisions in three-body problem for mu tends to 0 can take place. It can take place when uniformly rotating minor mass have collision with a massless body. Here is a system of equations, and when he wrote this equation in implicit formula, where tau is the time when this collision takes place, and eta is a true anomaly of the massless body. And at the right part of this slide, we can see a numerical solution of this equation. It's a picture not from his original paper of 1968, but from his book, where he recompute his picture one more, and he demonstrates very accurate technique for solving such an equation. And using this numerical solution, he firstly understands the structure of generating solutions of the three-body problem. So you can see notation, maybe not very accurate, but this is the old names of generating families. A, B, C, he described these cases. And the new notation, capital S with two indices, it's new notations that he used in his book devoted to generating families of three-body problem. So let me give maybe a strict definition. What do I mean when I say about generating solution? So if we can write our Hamiltonian in such form, where H0 is unperturbed integrable part, and this term is our perturbation, so we can search for periodic solution of this perturbed Hamiltonian system in such way. We try to understand the structure of periodic solution of unperturbed problem, and then we try to continue to the case when mu just near the zero. So the definition of generating solution is, if we, for small value of parameter mu, have a periodic solution of the perturbed problem, and this solution can be continued to the limit case where mu tends to zero, and if this limit exists, so we will call this limit solution generating solution. So from this definition, it's clear that the structure of generating solution depends on the structure of perturbation. And generating solution maybe is not a solution in the strict sense of the unperturbed problem. Because if our perturbation has a singular point and at mu equal to zero, this singular point disappears, so we can use a number of generating solutions to link it together and to obtain new generating solution. So Poincaré proposed such a kind of classification of generating solution, but in his book he mentioned first species. It's the case of regular generating solution, when our solution is far away from the singular point. But Hénon, using this definition, using this classification, proposed two new species, the second species and third species of generating solution, and his work was devoted just to investigation of generating solution of the second species of three-body problem. Two more papers at that period was devoted to Hill's problem. Hill's problem is such a limit case of the restricted three-body problem when we try to understand what's happened with the massless body when the sun is far away, and we're interested in the motion of the massless body around the minor. But we save the potential of the sun, and the field of the sun become parallel. But this problem may be slightly easier, but still non-integrable. It was proved by Carles Simó with co-authors maybe at 2002 in some paper. So here you are Hamiltonian equations of motion and first integral of this problem. And here is two papers of Michel Hénon devoted to Hill's problem. And Michel returned to this problem thrice. The second return was at the middle of 17th, where he investigated vertical stability in the case of special case of Hill's problem. And the third return to this problem was in two last papers of Michel Hénon devoted to new families of periodic solution. In one paper, he described 7 new families that he computed with the help of generating solution technique. And in the paper of 2005, he described asymmetric solutions that he obtained with the same technique. So here is 2 pages from these papers. It's well-known characteristic of the families that was recomputed by Hénon. And here is the pictures where Hénon demonstrates the presence of dynamical chaos in Hill's problem. He called these solutions half-ergodic solutions, and shows that in some case Hill's problem numerically shows that in some case Hill's problem cannot be integrable because possess such a kind of solution. In 1919, Bruno published in Russian his book devoted to three-body problem, where he tried to describe families of periodic solution with the help of generating solution technique. And Professor Chansonnier, who is here, was the first reader of this book, but in Russian case. I'm clear? This book is a collection of earlier Bruno papers that he wrote from 72 till maybe 88. Many of these papers were translated by Hénon from Russian to English and was published in Celestial Mechanics, for example, with the help of Michel Hénon. So Hénon was very interesting to understand what Bruno did in this field, and he learned Russian just enough to understand what Bruno wrote in his papers. And for many years, Hénon thought that Bruno do not know English. And sometimes Hénon translated his paper in English, but Bruno decided that some phrases not correct. And he said to Hénon his version of translation. Hénon said, you know English? So I want to say that such a collaboration between Hénon and between Bruno leads to new results. And after this book of Bruno, Hénon published his answer. He published the first volume of the book in Springer, Generating Families in the Restricted Three-Body Problem, where tried to, in very accurate manner, very clear, on my opinion. After reading Bruno book, I can say this. It was written very clear to describe the modern situation in this field. If you open this book, you will find in the chapter 10 the phrase, this chapter devoted the such situation when there is a number of generating families and there is a number of real families. How these generating families connected with real families? This chapter was written under the influence of Bruno. It was written in this chapter. But Hénon wrote such a phrase, I do not understand how Bruno obtained these results in his paper, but I think that it is correct. When Hénon prepared his second volume, at that time Bruno published his book devoted to technique that he developed for the last maybe 40 years. It's power geometry technique. And this technique is oriented to solve, to obtain solution of algebraic and differential equations even in singular cases. And this case is just the same case as Hénon tried to understand in the restricted three-body problem. So Hénon write two chapters in his second volume where he tried to use Bruno technique for strict background of his results that he described in his first volume. Here is a small extraction from the list of Bruno papers where he tried to continue the work of his own and the work of Michel Hénon, devoted to understanding the structure of families of periodic solutions. I want to say that, on my opinion, I can compare the results that obtained Michel Hénon and the results that obtained Alexandre Bruno, that, from my own opinion, many difficult things became clear for me only due to plain and very accurate language of Michel Hénon. Thanks to Hénon. Thank you very much.
Any questions or comments?
Yes, there are only 2 books, Springer books, but actually there's a lot more result. And I had long discussions with him about a possible 3rd book, and so he decided that the notes that he has, they are fairly well organized, and so anybody who wants to know more can access these notes. I don't know if they have been scanned yet, but they probably will be, and it is useful to have that. Okay.
Pas d'autres questions? Alors, je remercie tous les speakers de cette session. Et je vous invite à aller prendre le café. On se retrouve à 16h15, je crois.